All right, here's the concept map about chemistry basics that I'd like to get into with you guys today. So let's take a look here. I'm going to travel all over this concept map here and kind of zoom in so that you can see what it is we're talking about. Let's start here with elements. So an element is a pure concentration of the same type of atom. Elements cannot be broken down further. They are what they are. There's no other anything in it, right? It's 100% pure. So where were we? We were just kind of at elements, right? Take a look. This is how you read a concept map. So atoms of the same type form elements. Notice how we are traveling down. We're using that arrow to tell us the direction to read. Take a look. Let's go up from atoms. Atoms are the basic building blocks of all matter. Let's go to the other side of our concept map. So matter is anything that occupies space and has mass. Mass and weight are very different. Mass is equal to the amount of something measured in grams, whereas weight is dependent on gravity. I weigh about 150 pounds wet, but that's 150 pounds on Earth. If I went to the moon, where the gravity is a lot less, I would feel a lot less. However, no matter where I am in the universe, I am made up of the same amount of stuff. So no matter where I am, my mass remains the same, but my weight is going to feel different. All right, let's get into it. Going into the middle of our concept map here. I'm looking at the middle. Elements combine to form molecules. Molecules are particles that contain more than one atom. Molecules made up of more than one type of element are called compounds, and common organic compounds that we'll discuss here in this class include carbohydrates. Carbohydrates are the sugars and starches, and they're made up of carbon, hydrogen, and oxygen. Proteins are another one of the organic compounds that we'll discuss. Organic compounds are compounds that are made with carbon or have carbon in them. Inorganic compounds don't. For example, water is an inorganic compound because it doesn't have carbon in it. Anyway, I'm digressing a little bit here. Proteins are made up of long chains of amino acids. And those are usually enzymes, or they provide structure within a cell. The order of amino acids in an enzyme, in a protein, proteins are made up of carbon, hydrogen, oxygen, and nitrogen. The order of amino acids in a protein are determined by the DNA sequence of nucleotides and the RNA sequence. Right? And DNA and RNA are made up of carbon, hydrogen, oxygen, nitrogen, and phosphorus. Phosphorus is a limiting nutrient within ecosystems. Phosphorus, it's not a lot of it available in, let's say, an aquatic ecosystem, and so when it is available, phosphorus is usually snatched up and used to grow. It's used also in ATP, which is that chemical currency that our cells use. So if you have a lot of phosphorus in an aquatic ecosystem, like I said, something like, let's say, algae might snatch it up and start to grow with it, right? Grow wild. And that could be a really bad, detrimental thing to an aquatic ecosystem, because that algal bloom will starve the lake for oxygen. It'll die, which would start to decompose and make the oxygen levels decrease even more. Phosphorus is very important in our discussion and study of environmental science. Another organic compound that we'll discuss here are lipids, and those are fats. They're also found in cell membranes. Lipids are also made up of carbon, hydrogen, and oxygen as well. All right, let's talk about water. So polar molecules are molecules that have a positive and a negative region to them, and water maybe is the most famous of the polar molecules. Water is sticky to other H2O. This allows for high surface tension in lakes or bodies of water, and it also allows for capillary action as well. pH of water is 7. pH is a measure of the amount of hydrogen ion in solution. Every so often, water, H2O, the H disassociates from the OH. So you have H and OH. And with water, there are equal ratios of H to OH in solution. And because of that, the pH is 7. Take a look at this Lewis dot structure of water. We've got, let's see, the oxygen is the central atom, and the oxygen is surrounded by electrons. In fact, oxygen's pretty electronegative. What that means is it's going to pull electrons towards it. Electrons are negative. So as oxygen pulls electrons towards it, it becomes slightly negative. Well, hydrogen is just a positive proton and one negative electron. And if hydrogen has its one negative electron being pulled away from it, that means it's going to then have a slightly overall positive charge. Hydrogen bonding occurs when more than one water molecule, the negative region of one molecule of water is attracted to the positive region of another one. This hydrogen bond lasts for just a moment, but it allows for water to exist in liquid form. It allows for water to exist in ice or in steam. In fact, if I took water and I really excited it, I increased its thermal energy and I increased its average kinetic energy, and the water starts to move around a lot more, the water molecules are going to have a harder time bonding, creating those hydrogen bonds between themselves. What happens is that, well, gosh, the water will just kind of float away in the form of steam. The opposite happens with liquid water. If we remove its kinetic energy and decrease its temperature, those hydrogen bonds will become a little bit more permanent and help create water and structure the water molecules into kind of a lattice structure, ice, in other words. Pretty fun stuff. Water has some really incredible properties that make life happen. Hydrogen bonds and this capillary action process occurs in a process called transpiration in leaves. Maybe you've ever wondered, how does water get to the top of a tree? Well, it happens because water is able to create hydrogen bonds with itself. So what will happen is the root brings the water in. Meanwhile, at the very top of the tree, a leaf has these little holes in it called stomata. These stomata, when they're open, the water will evaporate out. So as the water evaporates out of the leaf in the tree, what will happen is that it will pull up, kind of like a straw, it will pull the water up from the roots up through the trunk into the leaf to replace it. It can be pulled up because it's slightly sticky with one another, right? It kind of comes up as if you were drinking out of a straw. Let's talk about some other polar molecules like acids and bases. An acid will contribute more H to solution. The pH generally is 0 to 6.9. Remember that water will dissociate into H and OH. And so an acid is classified as something that has more H than OH. So it's not going to have a pH of 7. It's not going to have equal amounts of H and OH. It's going to have a pH of something less than 7. So the concentration of H is greater than the concentration of OH or hydroxide. A base contributes more hydroxide ions to solution, and the pH is going to be higher than 7. The concentration of hydrogen is less than the concentration of OH. All right, and we're going to finish our discussion here with chemical reactions. So matter cannot be created or destroyed, but it can be transformed from one form to another. This is a classic combustion reaction. I've got methane, CH4, and when it combines with O2 along with some energy, the reactants right there. So when CH4 and O8 and O2 combine through a chemical reaction, it will produce carbon dioxide and water. In fact, any combustion reaction will always create CO2 and H2O. The reactants in this case here are the methane and the O2, and the products are on the other side of the equation here, CO2 and H2O. Take a look. One thing that's not happening here, I'm going to go back a click There we go. Take a look how the number of oxygens on the product side is 3. The number of oxygens on the reactant side is 2. 2 does not equal 3. So what we need to do then is balance these equations oftentimes, right? We've got to look to see how many carbons, hydrogens, and oxygens we have on the left and make sure that they have the same amount on the right. The reason why we need to put a coefficient of 2 in front of this O2 and a 2 in front of the H2O is so that the amount of C, the amount of H, and the amount of O is always the same. If that didn't happen, then we would be violating the law of conservation of matter. Thank you for listening. Let me know if you have any questions.